Hey Pre-Calculus, in this video we're going to be talking about 4-6 inverse trig functions. So we've dealt with regular trig functions, right? What's sine of pi over 6? So in your brain, hopefully you're thinking, okay, well sine is the y value, so what's the coordinate of the y value at pi over 6? That's 1/2. But what if we know that sine of x equals 1/2? Now we need to learn about the inverse. So a function has an inverse. Unfortunately, it's not just as easy as looking at the unit circle. So a function has an inverse if, actually I should say an inverse function, because that's going to be important. If and only if, which I can write this way, if and only if it is 1-to-1. So what the heck is 1-to-1? 1-to-1, didn't we talk about this? I feel like we talked about this, but 1-to-1 basically means, so you know a function, right, is if every x has only one y. So a function's 1-to-1 if its inverse is also a function, meaning for every y there's a unique x. So if we think about our trig functions, right, sine and cosine, the sine function fails the horizontal line test. And notice I said horizontal line test. Not vertical, right? So sine passes the vertical line test, which means it is a function, but it fails the horizontal line test, therefore it's not 1-to-1. And I literally just said it only has an inverse if it's 1-to-1. And I'm just going to do a little sketch, right? So if we went up, sine function goes up to 1, down to -1, just to give you a visual. Pi over 2, pi. It's been a while since we've done this, so let's give you a little visual of the sine function. Okay, so pi over 2, negative pi over 2, 0, pi over 2. Alright, so this is my sine function. Hopefully you remember from our last chapter. So this is the sine function. It is a function, right? But it isn't, its inverse won't be a function. So that means there are no inverses of sine. And hopefully you're like, well, hang on, yeah, there are. I've done right triangle trig. I have solved for a missing angle. And when you do that, you use inverse sine. Well, there's a reason for that. So this whole function is y equals sine of x. If we restrict the domain to be negative pi over 2 to pi over 2, okay, let's take a look at that. So that's from here to here. Then it's 1-to-1, right? Then it passes the horizontal line test. The restricted function is 1-to-1. And that's kind of the fun part about math, right? If we don't like something, we find a way to manipulate it and make it what we like. So that's what we do for the inverse function. So we focus on just this restricted domain. Okay, so the last thing I want us to take note of before we do some examples are, so because angles and arcs have equivalent radian measures, on the unit circle, the inverse sine is sometimes referred to as arc sine. So you guys are used to seeing inverse sine, and it's not written out this way, right? It's sine with the little exponent of -1, but you could also write it as arc sine. So sine of pi over 4 is equal to root 2 over 2. Hopefully you guys know that one from the unit circle, right? So if I say what is arc sine of root 2 over 2, this is asking what angle between negative pi over 2 and pi over 2 has the y value of root 2 over 2. Sorry, you can't see that. Okay, so good my unit circle. I'm like, okay, so between negative pi over 2 and positive pi over 2, this is a positive y value, so that means I'm in the first quadrant, so that's going to be pi over 4. Okay. So it can't be anywhere where there's positive root 2 over 2 because there's two spots, remember, quadrant 1 and quadrant 2. It depends on the domain restriction for inverse. Now, it's similar for cosine and tangent, but not exactly the same. You do need to know all of them. So similarly, the inverse of cosine and tangent have restrictions. And I'm not going to do the whole graphs like I did above, but it's for the same concept. And this is why when you do inverse calculations in your calculator, it does give you an inverse because these are the domain restrictions. So here are the three rules. So this is how you're used to seeing them: inverse cosine, inverse tangent, inverse sine. Make sure you are familiar that they can also be written as arc cosine, arc tangent, and arc sine, like we did above. So they could be written any of these ways. And cosine is restricted from 0 to pi, so quadrant 1 and 2. Tangent is restricted with soft brackets from negative pi over 2 to pi over 2. And it's soft brackets because it's undefined at these two values, right? So we know it's undefined. And then the restriction for sine we've already talked about, but I'm going to write it again. So hard bracket, negative pi over 2 to pi over 2. So before you can do the inverse trig, and this is going to be really hard if you don't know your unit circle, before you can do it, you need to understand the different kinds of brackets. So just a couple examples. So if I have inverse sine of 1/2, so I'm thinking a couple of things. First of all, I'm thinking, okay, sine is my y value. 2, I'm thinking y value of 1/2. 3, I'm thinking domain restriction between negative pi over 2 and pi over 2. And I want this in radians. Safe to say, always radians, no degrees, unless the directions say otherwise. So when is my y value positive? It's in the first quadrant. And so that's going to be pi over 6. Sometimes I like to draw a little picture if I'm rusty. Alright, so example 2. Let's do cosine inverse, or inverse cosine of negative root 2 over 2. So first I'm thinking x value, because it's cosine. It's negative, and my domain restrictions are going to be from 0 to pi. So when is the x value negative root 2 over 2 within those quadrants? And if I'm thinking, like I said, you could always do a little scrap work over here and be like, okay, so here it's positive root 2 over 2, here it's negative root 2 over 2, so that's going to be 1/4, 2/4, 3/4. So 3 pi over 4. Let's do one more example. We'll do tangent. And we'll write it with arc this time. So it's arctan of the square root of 3. So arctangent, and think of our tangent restrictions. So that is between negative pi over 2 and positive pi over 2, right? Arctangent is positive, so that means I'm going to be in the first quadrant. And then you have to remember, okay, so it's root 3 over 3, 1, root 3. So that's going to be at pi over 3. So if you want to draw yourself like a little sketch to kind of just like help you get there, or you can do this in your head. Either way works, but we should not be using a physical unit circle. You should know these at this point. And that's it. Don't forget your domain restrictions. That's what's going to kill you. Because, right, tangent is also positive in this quadrant over here, but that's why we have those domain restrictions, and that's what your calculator is doing when you do inverses.